Hello, mathematicians, puzzlers, and other curious people. I hope you saw my blog post yesterday about this puzzle. If you didn't already see it, you might want to click over there and take a look at it really quick. So it's got this nice little grid of numbers in it. I'm going to show you some things about that puzzle today, not just about how to solve it, because that's fairly straightforward for most mathematicians, but about how to set up more ones like it. So if you haven't already taken a look at that and tried to figure some things out, you might want to hit the pause button right now and click on over to the blog. I'm going to go ahead and go on now. So here's what we've got in this puzzle. Okay, so we've got the numbers. Let's see. 6 plus something comes out to 8. So there's one equation. Also, 6 minus something is 2. Let's see, that first thing plus 3 is some other number. That second thing minus 3 comes out to some number. And 8 minus the number we just came up with comes out to 7, but at the same time 2 plus this number here that we came up with a bit ago comes out to 7. So this puzzle itself is not all that complicated to figure out, as long as you know basic addition and subtraction. So what I'm seeing here is, well, 6 plus something is 8. Well, that could be a 2. 6 minus something is 2. Okay, that's a 4. Okay, 4 minus 3 is 1. 8 minus 1 is 7. That works. And let's see, 2 plus 3 is 5. 2 plus 5 is 7. Well, that works. Okay, so that was really simple. Now, the question I asked after this was, can we change, is this guaranteed to always work, or can we change the numbers to make it impossible? And one thing I suggested is if you change that middle number, I think what I came up with was a 2, is, well, then we'd be saying 4 minus 2 is 2, 2 plus 2 is 6, and so, 2 plus 2 is 4, and then 2 plus 4 would be 6, but we've got a 7 here. 8 minus, okay, so this doesn't work. Okay, so clearly these numbers determine each other in some way. And what I'm going to be trying to do in this video is come up with some relationships between these numbers. Now, in the interest of honesty, I'm not trying this for the first time in this video. I got notes. So, like I said, if you haven't already tried this sort of thing on your own a bit, I'd like to see what you come up with. I'd like at least for you to find out what you come up with, and feel free to put it in one of the comments sections, instead of just jumping straight into this, which would be a little bit spoilery. Okay, so I said, well, we've got 4 unknowns here, and it's fairly usual. This came to my mind because I'd just been doing some linear algebra the other day with a client. It's fairly usual when you have 4 unknowns to call them w, x, y, and z. And then when you have a certain amount of things that you do know, often values that you do know, like coefficients of a polynomial, get referred to by letters from the beginning of the alphabet, so like A, B, C, D, and E. Now we saw here that the values of C and E have to be compatible because of things that happen from W, Z, X, and Y, but then X is determined by A and D. Let's see, Z was determined by D and E. Let's see, Y was determined by B and E. So the whole thing kind of has to fall together a particular way, or the puzzle becomes impossible. So I noticed, and the version of this that I ended up doing was built around C, but you could probably do this for other combinations of them. So I noticed, if we have the equation that A plus W equals B, Well, then we could use the related equation, W equals B minus A. We're just subtracting A on both sides, or using one of the subtraction facts from the same fact family. Let's see. So we started with that A minus X equals D. So X is A minus D. Again, it's another fact from the same family, or another way of writing the same number bond. You could diagram that out and say, okay, if A minus X is D, then if we want to know X, we would do A minus D. Okay, I also wanted to come up with a formula for Y. So I used the fact that B minus Y equals E, and I got kind of a similar looking formula. So for the same reason, Y is B minus E, and then Z. Let's see, so D plus Z equals E, so Z would be E minus D. Now there's something that by kind of working around the edges I skipped entirely, and that's C. So I came up with two formulas for C. But I'm just going to start off by stating a basic fact. Whatever number C is, it equals itself. Like 4 equals 4, up here it was 3, so 3 equals 3, etc. Whatever number we put in the middle, well, it has to be the same as itself, because that's what being equal even is. Okay, I came up with two formulas for C. So C, well, vertically, we have that W plus C equals Z. So C would be Z minus W. But C also, going horizontally, we had that X minus C equals Y. So C could also be written as X minus Y. Okay, so now what I'm going to do is take both of these and substitute them in to this. So I'm going to say this first Z here, I could calculate it by doing Z minus W. This second Z here, I could calculate it by doing X minus Y. But wait a second, those are still equal because they both come out to C. Okay, well, I had a way to get Z, though. And so I said, okay, Z was just E minus D, and W was just B minus A. Now I've got to be careful. I want the result of that subtraction to be what gets subtracted off. Just a moment, let me get the rest of that. Okay, now the next thing I said is, alright, whoops, wrong color. Okay, the next thing I said is, well, wait a minute, I could also rewrite that X as A minus D. I can rewrite that Y as B minus E. And again, I'm going to carefully make sure that that's the result of the subtraction that I'm subtracting off. And so then those things also should come out the same. So we've got two ways we can calculate C now. That's quite surprising. And another thing I notice is that we've gotten rid of all our unknowns from the back of the alphabet, so we can calculate C two different ways from the other four clues, A, B, D, and E. But we've got two different formulas here. So then there's a concern that does that come out to be contradictory if we've got two ways we can go about it? Now, you shouldn't be surprised that in math there might be two ways we can do a thing, because that happens a lot. There ends up being more than one method. But when we've got two formulas, the concern that comes up is what if those formulas don't always agree? What if they might diverge? So one thing we can do is simplify those formulas. So I'm going to go ahead and distribute this subtraction. A little bit of algebra here. A little bit of algebra running around all over the place, actually, but just remember these letters are just sort of stand-ins for some number. Negative times negative is positive. Okay, so now I'm just going to move some terms around and put this in alphabetical order. And what I've got here is A minus B minus D. Let's see, E was positive, so plus E equals... Oh, well, this is easier to put in alphabetical order. I can just switch around the B term and the D term. So A minus B minus D plus E. Okay, so it turns out that these two different ways of writing the formula are really equivalent to each other, so we can, in fact, trust that that's going to always come out that way. So that middle number C needs to be A minus B minus D plus E. So now we can make one of these up anytime we want by just plugging in different numbers around the edges and calculating that middle number to match. So what I'm going to do is erase the clue numbers. I've got to get that 3 out of there also. And I'm just going to pick random numbers. So let's see. 14, 27, 9, and let's see. I want to be between 9 and 27 because this one's adding, this one's subtracting. So let's go 18. Okay, so now I'm going to try out this formula. So C equals A minus B minus D plus C. It just occurred to me that we could say C stands for center because it's in the middle. Okay, so I hadn't even thought of that until just now. Okay, so out of this example, A is 14, B is 27, D is 9, and E is 18. Let's see. Positives and negatives. So 32 minus 36. Negative 4, huh? That's a weird one, but let's try it. So if I put a negative 4 there, let's see if this works. Okay, so 14 plus 13 should be 27. 14 minus 5 should be 9. Okay, let's see. 14 minus 5. Okay, so 9 plus 9 should be 18. So now let's see. 13 minus negative 4. Or sorry, 13 plus negative 4. My bad. That was starting to make me worry. Okay, 13 plus negative 4. Well, that's the same as 13 minus 4, which is 9. Like is compatible here. Okay, and then 27 minus something is 18. Well, that's 9. Also, 5 minus negative 4 is the same as 5 plus 4, which is 9, like we want that to be. Okay, so we could make some more rules if we want to avoid negatives, and that sounds like another good direction for research. If any of you want to do some follow-up problems based on that, maybe I'll do one based on it some other time. Now, other things. One thing is this formula right here for that center clue number is a result of some calculations that we did using these signs. So if you have different kinds of problems that you're doing. You know, if you mix up in a different order which ones are addition and which ones are subtraction, or if you bring in things like multiplication, this formula probably won't work. You would need to come up with a different center number formula. So I think that's an interesting place to stop for now. So feel free to go on and do some further work with this. There's definitely more interesting stuff that can be done, and as you can see, a lot of the time setting up a puzzle can be even more interesting than doing the puzzle itself. So until next time, calculator.